All right. So the purpose, as I mentioned, for these meetings is to have the ability of everybody to ask questions as we go along. If things come up that you're just unsure about, you want to bring it up or you want it clarified, that's a good thing. I do have videos that review through the end of the chapter questions. So rather than just going through that, I'd rather not spend the time where everybody's sitting here, because you can do that on your own. Now, after the first couple of weeks here where everything's foundational, we'll get into doing some design problems. And if you have a project that you want designed, I know one of the folks who was in this, trying to remember his name, he's not here right now, but anyway, wanted us to design his DC coupled system that he wants to install. So if you've got a home or a project that you would like to have as an example, we may as well use real world data when we're doing a design problem. So, but you're not ready for this yet, because you haven't gone through the how to size the wire, how to select the equipment, how to use some of the remote site assessments and what you would even look for, and then how you size the array and how you would do a string. And, there's a bunch of stuff that's in your future. So, but we'll do this all, putting them together. So at this stage, you should probably be through, hopefully, with chapters 1 through 3. That would be the ideal. I just set up a group today. You may have gotten an email that said you'd been entered into a group. I'm not quite sure. Does it send those things out to you guys? Did you get an email saying you were just enrolled in a University of Dayton group?
I didn't get one specifically. I've just been getting your.
I don't think I got one of those either.
Okay. All right. So I guess when I set up a group like that, unless I specifically invite you, you probably didn't get one. Okay. Well, you're in the group. So now I can go in and spy on you. I can see if you've actually opened up a lesson and how far you are in these lessons and things of that nature. So that's something that's good within this system. Anybody having issues with the technical aspects of the course, audio issues or getting into it, password issues, nothing of that sort? I know
email that you did, we figured it out. So
okay.
doing it in Edge, in the browser Edge, fixed most of the audio issues I was having.
Okay, were you using Chrome by chance?
I believe I was on Chrome, yeah.
Yeah, Chrome seems to be the buggiest one when it comes to that particular system. And it's kind of a moving target, because every time they do a browser update, or upgrade, sometimes these problems reemerge, and so it's not like I can just fix it and it stays fixed, because it changes. So yeah, I found that Edge and Firefox tend to be pretty stable with this. I'm thinking, though, when I do the revision of it, and maybe we can test it with you guys if I have a sample of, rather than using PowerPoint slides and having you advance through it, I think I'm going to just record these things like they're a video, walk you through, let each section just play, because that way there won't be compatibility issues. It'll just play like it's a YouTube video, and pretty much everybody is good with that. Have you found that the PowerPoint is helpful moving back and forth, or when you go into a section, you typically just advance through the slides till you get to the end of the section? Does that make sense? What any feedback on that at all?
I thought it was pretty intuitive. I think I've gotten through the first few chapters, and I had a little bit of buggy, audio issues, probably because I was using Chrome, but no, it flowed fine. I thought it was fine.
All right. Yeah, I'm just working on these things because I'm doing the level 2 course right now. And what you guys are in is the introductory residential course. But then there will be a follow-on. There's a textbook that just was published that goes into commercial design and installation. And then there'll be a commercial online course as well by the end of the year. So if you find that you get into this as an industry and you want to advance, then there is a second level that's coming where, you know, you get comfortable with the residential end, but then if you want to go into commercial design and project management, do some of the financial stuff, we get deeper into that. But in this course, we're really just the whole focus is, how do I design and install a system on a house? You know, that's kind of where we're at. And then later we can get into financial management and you know, issues around commercial and project teams. And, you know, it gets just, the concepts are the same. It's just a little bit, the stakes are a little bit bigger, you know, a lot more players involved, things like that. So, all right. Well, any issues that came to mind as you were going through these things that we want to address? If there are none, we'll make this short and sweet. If there are, we'll address them in full. So anybody have anything there? No? Okay. Well, that's sweet. So in the meantime, during the week,
when you got a second.
Yeah, if you do get into any issues, feel free to contact me individually as well, because sometimes people don't like to, you know, bring up something you think everybody else knows what you're talking about, or what everybody else knows the answer and you don't. You feel stupid, but I'll tell you, usually you're the one who everybody else is thinking the same thing. So. Yeah, Paul?
Do you have a question for you?
Sure.
Yeah. So this is a practical question. It's not necessarily related to the material. I've been doing some experimentation with some of the solar controllers. And what I'm finding is when I take the wires from the solar array or any of the solar panels that I'm using, sometimes they're quite thick in gauge, 12 gauge or 10 gauge. And when I attach them to the controller, you screw them in, they're kind of tight, but whenever you use some these charge controllers that just have the screw adapters where you screw them tight and they kind of press the wire, they tend to fall out. And I was wondering, can I solder those and have them like fit tighter? Is there a connector that you would use for putting on top of that, so that when you do put it into these screw adapters that they don't tend to ease their way out? Have you had any problems with that yourself?
I haven't had any problems. Now, charge controllers, I assume you're talking about charge controllers per se, right? These are standalone systems that you're dealing with?
Yes.
Yeah. And are these, what's the brand, do you know, that you're using?
They're different types. One of them is Renogy or.
Oh,
Renogy.
yeah. Renogy.
Yeah.
Okay. Yeah, they're oftentimes now with some products, they have the you know, the connector ports where you push a screwdriver in, slide the wire in, and then release. You know, those tend to be pretty stable. But is the one that you're using, is it a would you be able to crimp on like a ring connector or a what do they call those, like the little C type slide in connectors? Can you crimp that on? Or
yeah, what I was thinking about is possibly crimping on one of those barrel adapter heads, and then pushing the barrel adapter head into the slot where it crimps down with the screw, and then seeing if that will, you know, stick better. But I don't know. It's just every time you move it, or every time if there's any like vibration or whatever, it just comes loose. I can't imagine people put these on RVs and boats and have them stay.
Yeah, I've never heard of that as an issue. So I wonder if it's just a specific product, or, you know, if it is a screw that you're screwing into, a ring connector would be pretty stable, you know, if you can fit that over. But it sounds like this is something you insert in and then screw it down.
Yeah, pretty much like if you look at any of the electrical panels, same thing. You put the wire in and screw the screw down.
Oh,
to clamp it.
Yeah. I've had that issue with some circuit breakers when we use them in class, and we use them a lot, and people tend to booger them up a bit. You know, where they do come loose in the circuit breaker. So yeah, I know what you're talking about. It could also be the type of wire you're using. Is it finely stranded, or is it thick strand?
It's not too fine, but I'm not sure what the individual gauge of the strands are. That's why I was thinking about, if I just solder the strands together, maybe they become a clump. And if I put the clump in there, I could, like, you know, screw down onto the clump, and maybe
I don't think
like that.
It doesn't sound like that would be an issue. You know, if you're just gooping up the end of your wires with some solder so that it gets a better purchase. Sounds like a solution.
Okay. Well, I didn't want to derail the class, but I
No.
thought I'd throw a practical question out there.
You brought this up because I just was getting an email from a former student up in Minnesota who's got a standalone system, and he's having intermittent issues with output from his solar array, where some days he's getting full production, and then the next day his charge controller will say he's only getting, say, 45 watts coming from the array, you know, very little amperage, but the volts are good. And then the next day it'll be 1,000 watts, but the conditions haven't really changed. And I wonder if maybe it's a loose connection, you know, within the charge controller, where, you know, a loose connection, you'll lose some of that wattage or some of the amperage. It just won't bleed through.
That's how I noticed mine, is in the difference in the output.
Yeah.
So it's probably that. Could be corrosion too. So if it's been up there a while, maybe it's got some corrosion.
Yeah, the problem, of course, I'm trying to diagnose it without being there. So I was telling him, well, why don't you put an amp meter on it and just follow the lines all the way down to the charge controller? If you're getting amps all the way to the controller, but not in the controller, then there's a problem with your controller. You know, if the amps aren't coming out of the array, then there's a problem up there somewhere. And it could just be bad cells within a panel. You know, they can affect the output of a string, which we'll get into, because it's like water going through a pipe. Wherever it's crimped down to the smallest is all the water that's going to go through. So if you've got a bunch of cells in a string, and one of the cells is shaded, or one of the cells maybe is having a problem, like by heat fade or something like that, then the output in the amps could be affected. So again, unless you're there to test things, oftentimes the best way to test things is just isolate each piece of equipment, test them as you walk down through the system, and then see where the problem manifests itself. You know, then, because it could just be a bad charge controller too. The controller could be going out because it's been installed. It's been 4 or 5 years up there. So these things typically only have about a 5 to 10 year shelf life. So
speaking of the amperage and measuring it, what would you use as a practical piece of equipment to measure that amperage that's coming out of the solar panel?
Yeah, oftentimes just one of those clamp-on amp meters. You know, because obviously with the amps, with volts, it's easy. You just use a multimeter and you put, you know, the terminals, because you could measure volt when there is no load. But with an amp meter, you just get one of those meters that has that little clamp, and it goes around the wire. So if this pin here is the wire, the clamp goes around it like that, and then it will measure the amps that are flowing through that wire. And so you just put it around the wire and in different places, and it should tell you how many amps are flowing through. But there's got to be a load connected. Otherwise, you know, if there's no load, there's no amps. You know, it's like, I mean, it is current. If the water isn't flowing, there isn't a current, you know. So in that analogy with the water, we always say that the volts is like the water pressure and the amps is like the flow or the current. Well, you can measure pressure when the taps aren't turned on, but you can't measure current unless it's flowing, unless it's going somewhere. And the load is where it goes to. So in this case, the inverter would be the load. You know, it would be then going off to either the grid or to the load. So you'd need to have some load going, or the battery. Battery can be a load when it's being charged.
So to follow on that, let's say you wanted to limit the amperage that was going to be able to come out of that solar array or solar panel. So when you've measured it, you've determined it's got too high of an amperage that you want to accept. What kind of device do you put there to limit the amperage that can go through?
Yeah, you put a circuit breaker, you know, a breaker or a fuse. That's pretty much the whole purpose of those. Now, obviously, at that point, you're going to be shutting down your system if it exceeds that amperage level. So you wouldn't do it just as a way of throttling down the amps. I think you can there are devices where you could do that, but I don't know of a reason to do it. You size your wire based on the maximum theoretical amps that could flow through given what you've installed. And then you can put a breaker or a fuse there to limit. That's usually done to protect the equipment in case for some reason it may have a spike or exceed the amps that you want to allow through that thing.
So there's no like practical throttle. It's just on or off if it exceeds the amperage.
Yeah, I mean, the charge controller does limit beyond that to a certain extent. It controls how many amps and how many volts are leaving it. So that becomes, you know, a controlling mechanism. And there's probably something that you can put in, but again, I don't know why you would. The controller is there primarily, the charge controller is there to control how the panels charge the batteries. So I don't know why you'd try and throttle down the amps before you get to a charge controller. Now, if it's not a standalone system, then your inverter is the first piece of equipment that's connected to the array. And that's where most of the control is going to be. But in a grid-tied system, you don't really want to shut down production of your array, because if you don't need it for your loads, you want to generate that power so it goes to the grid. So you want it producing at maximum all the time. Now, the nice thing about solar is it is self-regulating in that if there is no load, it will automatically not go anywhere. There will be no amps flowing. There will be no voltage flowing through the system. So you don't need a mechanism. For instance, let's say your batteries are fully charged. You don't have load demand, or you have minimal load demand. The panels themselves will only send enough energy to meet the load and no more. You know, the analogy I like to think of is like a vacuum pressure kind of thing. The more you release the pressure, the more will flow out of that water tank. But if there's no load, no pressure to be released, then it's not going to go anywhere. Does that get to what you were looking at there, Paul?
Oh yeah, absolutely. I'm really interested that the solar panels self-regulate themselves and only allow you to have what you can consume.
Yes.
So I'm
yeah,
curious what the electrical background is, you know, in that solar panel to make that happen. But I'm not that deep in electronics to be able to understand it probably at this point.
I think it has to do with the very nature of the way that the photons and the electrons operate within the cell. It's essentially a diode, and it only allows the flow through when there is a load to service. Now, that's not the case with generators such as wind turbines or generators, where if they're running, you have to have some place for that load to go. solar is good that way because no damage is going to happen. Imagine you take a solar panel and you just put it out there in the field in the sunshine and it's not connected to anything. The panel itself has the potential to generate power, but until you hook a load up to it, nothing's going to happen. But the panel itself is not going to be damaged. Contrarily, if I were to put a wind turbine out there and start spinning the blade, that power's got to go somewhere. Otherwise, it's going to burn up the internal components of the system. So that's a big advantage of solar over a turbine type generator, is you don't have to have a load dump that takes the power whenever it's available.
So auxiliary question with that. Why do they require you to hook up the battery to the charge controller before you hook up the solar panel? If the solar panel is not going to like overload the charge controller, why do they have you hook up batteries to the charge controller before the solar panel?
Yeah, because once you hook up your solar panel to the battery, you got a load, and that load could be discharged very quickly. So basically it's like saying, okay, hook up the batteries to the charge controller. Now hook up your panels to the charge controller, because the controller is going to control how the battery is charged. The controller, it's like if you short circuit a battery, if you discharge it all at once, you can get, sparks and a big mess. So what they're saying is, in order to avoid damage to your battery, hook up the controlling unit first, then hook up the power source to that controlling unit, so that you don't damage your battery by trying to charge it too quickly or shorting something out. It's like you never hook up a live load to a piece of equipment. You always want to turn it off first and hook it up to the disconnect. So I think that's where they're coming from there. It's just a better practice. 99 times out of 100, you probably wouldn't have a problem, but doing it that way, then 100 times out of 100, you're not going to have a problem.
Okay, sounds great. Thank you.
Okay. All right. Any other questions? Okay, doke. All right. Well, why don't we plan on meeting here now? Also, I'll invite you guys again. We hold a Zoom session the hour before this at noon. And that's something you're all invited to. I don't know. I couldn't see people this time. I tried it a different way. Was anybody on that call at noon today in the group? Brandon, you were there?
Yeah.
Okay.
Yeah.
Yeah. So it's interesting to get perspective of other folks in the industry. So that gives you, hopefully my new template and everything wasn't too distracting. I was playing around with the software thing. So it was my first attempt. I think it went all right. All right. We'll see.
I think it was good. It was a little extra flair.
Yeah, a little jazzier. So
yeah,
we'll see. The only problem that I had is all I could see was me. I'm used to seeing people and so I don't know if there were 2 people on the call or 75. It's
there
like,
was 20. There was 22, I think.
Oh, that's good. That's
yeah.
good. Yeah, and then I post those things on YouTube, and we usually get another 100 or so go in and look at that. Once you're registered with ETA, once you have your certification, there is a requirement that you have 8 hours of continuing education each year to maintain that over the 4-year period. So 32 hours over 4 years. These Solar Noon Tuesday meetings are approved for half an hour of continuing education from ETA for each one. So that's one way of getting some free training. They're pretty mellow about what involves continuing education. If you go to some vendor specific training, that would qualify. You're just going to need to get some sort of certificate or something that tells ETA that you have indeed done your training. So I've set up my Solar Noon Tuesday that if you go into the website, it's on the same page where you've accessed the residential program, the online courses. If you scroll down a little bit on that page, you'll see a whole list of free Solar Noon Tuesday webinar type things. Go in there, view the video. As soon as you're done viewing the video, it'll generate a certificate and it will automatically send that certificate to ETA. So they'll put it in your file. So you don't even have to submit it or anything. It's just there. So.
And that's on the website?
Yeah, it's on the same page on the online courses page on the solarpvtraining.com website. And just scroll down a little bit, you'll see a list. There's probably a year and a half of those things all accumulated in there. So if you want to look back through, look at old sessions, you'll get some, or wait until after you get your certification, then you'll get all the free training and it'll apply. Any training you get ahead of your certification doesn't count. You've got to be certified and then get your continuing education. So, all right. Okay, well, we'll see you guys next week. And in the meantime, if you have any questions, just send me an email or give me a call. All right. Take
Hey,
care.
Jay.
Bye-bye.
Thank you.
Jay, I have a quick question.
Sure.
Jay?
Yeah.
So it looks like we're supposed to be up to chapter 3 right now. What would you say? Is it usually 3 chapters a week, or what are you thinking?
No, usually I'll try and keep you guys abreast of that. But from now on, you know, chapters 4, well, not so much 4, that's basic electricity. 5 is a really long chapter. So next week, if we can get to starting on 5, then chapter 7 will usually take about 2 weeks to get through it, because that's when everything sort of comes together. And then 9, 10, and 11, that all happens quick. So that's like 1 week. So you're going to see that 4, 5, 6, 7, those are probably going to be 1 per week, somewhere in there. So for next week, if you could get through 4 and then begin on 5, that would be good.
Cool.
All right.
Yeah, and also I just wanted to mention that I do have I just bought some property in northern Michigan, so I have a small cabin that I was going to have some solar put on. So it was just something I wanted to kind of bring to class for a real world installation, kind of see. So cool.
Do you
Thanks a
think
lot.
it's going to be is it going to be a standalone, or is it connected to the grid?
Yeah, there's no you know, utility lines near it, so it doesn't have the possibility of integration. So it'll be a standalone unit.
Okay, that's good. That'll be a nice standalone project to do as a real world example.
Cool.
All right. Okay, great.
All right, thanks, Jay.
See you
Have
later.
a good one.
You too. Bye-bye.